Stoichiometry. You must know at the beginning what is meant by MR. This for calculations of moles. You must know at the beginning what is meant by MR as a molecular mass. MR, this is a molecular mass, and it is mass of 1 mole. Like, for example, if you want to calculate the MR of each of the following: Na2CO3, H2SO4, CaCO3. How to calculate the molecular mass for each of the following? We have from the periodic table the mass number. We will take the mass number of each element, and then you will find that Na is 23 in the periodic table, multiplied by 2, this is the number of atoms that we have, plus carbon is equal to 12, plus O is equal to 16, multiplied by 3. After that, you must know that for number of moles, how to calculate number of moles. Number of moles is equal to mass
over molar mass.
over molar mass. This in case of solid. Concentration multiplied by volume decimeter cubed in case of liquid. Volume decimeter cubed over 24 for gas at RTP. Number of particles or molecules or atoms or ions over Avogadro's number, which is equal to 6.02 times 10 power 23. So we have formulas for number of moles. How we calculate number of moles? How can we know this mass over molar mass or concentration multiply volume or volume over 24 or number of molecules over Avogadro's? It depends on the givens that you have. For example, if you have gram or kilogram or ton, it means that you have a mass. If you have centimeter cubed or decimeter cubed, it means that you have volume. If you have mole decimeter power -3, it means that concentration. If you have molecules or atoms or ions or particles, that you have this law. For example, calculate the number of moles in each of the following. Number 1, 46 grams of sodium, 500 centimeter cubed of HCl, 0.2 mole decimeter power -3, 48 decimeter cubed of oxygen gas at RTB, 3.01 times 10 power 23 atoms of sodium. For the first one, you will find that number of moles is equal to, we have mass, so it will be mass over MR. It is equal to mass that we have for 6. And then MR for sodium 23, it equals to 2 moles. For the second one, number of moles, we have concentration and volume. So number of moles is equal to concentration multiplied volume decimeter cubed. If we have centimeter cubed over 1000 to be decimeter cubed. So it's equal to 500 multiplied by 0.2 over 1000. This is the volume multiplied concentration and then over 1000 to be decimeter cubed.
0.1, sir.
Okay, zero point 0.1 more. After that, for the third one, 48 decimeter cubed is volume of gas at RTP. So number of moles is equal 48 decimeter cubed over 24 equal to 2 moles. If we have it with centimeter cubed, we will make it over 1000. For the last one, number of moles is equal to, for the laws here, we didn't write, number of moles is equal to volume decimeter cubed at R to B over 24, so is equal to 48 over 24. Is equal to 2 moles. For the last one, number of moles is equal to number of atoms. So for this law, we have number of atoms or ions or molecules or particles over Avogadro's 6.02 times 10 power 23. So it's equal to 3.01 times 10 power 23 over 6.02 times 10 power 23 is equal
So where
to
did you get 6.02 from?
0.5 more. So
Or
after
is that it
that,
for the topic?
so after that, you will find any atom contains 1 mole of any atom or any particle or any molecule, 1 mole of any materials contains mass is equal to molar mass. Volume at R to be 24 decimeter cubed. Number of molecules, Avogadro's 6.02 times 10 power 23. After that, if you have the number of moles and then multiplied by molar mass to get the mass, multiplied by 24 to get volume decimeter cubed at RTP, multiplied by 6.02 times 10 power 23 to get number of molecules over concentration to get volume decimeter cubed of liquid over volume decimeter cubed to get concentration of liquid. How we obtain this? By making cross multiplication. Number of moles multiplied molar mass to get the mass. Number of moles multiplied by 24 to get volume decimeter cubed. Number of moles multiplied Avogadro's to get number of molecules. Number of moles over concentration to get the volume. Number of moles over volume to get concentration. In case of C2H5OH plus 3O2 gives 2CO2 plus 3H2O, And then we have given only 23 gram of ethanol, and we need to calculate volume at R2B for oxygen, concentration for carbon dioxide. If we have 500 centimeter cube of carbon dioxide, and the number of molecules in case of water and the mass of water. At the beginning, we have mass, so number of moles is equal to mass over mR. So we must calculate mR of C2H5OH, it will be equal to 46. So the number of moles is equal to mass 23 over molar mass 46 to be 0.15. This to calculate number of moles. Step number two, mole ratios. This one from the balancing equation, 1, 3, 2, 3. After that, we have the new one will be 0.5. 1 gives 3, so 0.5 gives 1.5. 1 gives 2, 0.5 gives 1. 1 gives 3, 0.5 gives 1.5. These are more ratios to obtain the new moles. After that, for the new moles, if we need to calculate volume at R2P, we'll take number of moles, the new one, multiplied by 24. To calculate concentration, we'll take the new moles over volume decimeter cube, so we'll make 500 over 1000, and then number of moles over volume decimeter cube to get concentration. For to calculate the mass, number of moles multiply molar mass, mass of 1 mole, so for 18 H2O. And if you want to calculate number of molecules, number of moles multiplied by Avogadro's.